Hi, and welcome to the video lecture on linear functions. All right, so today we're going to learn ways to represent a linear function, how to determine if it is increasing, decreasing, or constant, relating slope or interpreting slope as a rate of change. We're going to write and interpret equations for linear functions, graph them. We're going to determine if lines are parallel or perpendicular, and finally we're going to be able to write the equation of a line parallel or perpendicular to a given line. All right, so let's get started. So what is a linear function? Well, a linear function is a function that has a constant rate of change. A constant, oops, that's not a pen, that's just a pointer. A constant rate of change. That constant rate of change is the slope of the line. Slope of the line. And linear functions are functions whose graphs are lines, which is nice because it'd be terrible if that wasn't true. So let's go with an example to decide if a function in a table is linear. So we're going to look at this function in this table, and we're going to decide if this table represents a linear function. So how do we do that? Well, we need to decide if it has a constant rate of change, a constant rate of change. So let's look at the rate of change between h equals 0 and h equal to 1. So the change in output is 30 minus 15, which is 15, and the change in input is 1. So my rate of change from 0 to 1 is 15 over 1. If we look at the next interval, you'll see the rate of change from 1 to 2. Well, 45 minus 30, that's again 15. 1 to 2, that's again 1. Again, we have a constant rate of change of 15 to 1. And as you look across the table, you can see that we increment by 1 each time here. And you got to make sure those are all the same. And we increment by 15 each time here in the output. Don't let them trick you by slipping one in there. So each time we increase the output by 15, we increase the input by 1, so the rate of change is 15. And we do know that this must be a linear function because it has a constant rate of change. All right, let's take a look at the second example. I want you to look at this example and decide if you think this table represents a linear function. Pause the video and see if you can decide if this function is linear or not linear. All right, let's go ahead and take a look. Well, when I'm looking at my inputs, I can see they all go up by 1, so I'm not going to bother writing that a whole bunch of times, but we can see that the change in input is 1 each time. Let's look at my change in outputs. Well, 4 minus 0, that's 4. So my rate of change from 0 to 1 is 4 to 1. Again, 8 minus 4 is 4. That's looking pretty good. Again, another change of 4 to 1. Uh-oh, nope, 12 minus 8. I'm not good at subtraction apparently. Still 4. We thinking this is linear? Don't stop now. Oh no. 20 minus 12. That is not 4. That's 8. So we have an 8 to 1 change. So right here, we can see it changed from being a ratio of output change of 4 to input change of 1 to output change of 8 to input change of 1. So this is not linear, and we actually call that non-linear. And if you're ever not sure, you can go ahead and graph these points, graph this function, and if the graph doesn't look like a line, it's not a linear function. All right, speaking of graphs, let's do these examples, and we're going to decide if they're linear functions, which is pretty easy. But let's, after do more than that, let's go ahead and find their slopes to kind of review slopes of lines. All right, so let's look at the first one here. It is a linear function. So yes, this is linear. It is a nice straight line. And in math, there are no curvy lines. There's only straight lines. So if I say it's a line, I mean it's a straight line. And let's look at the slope of this function. Remember what the slope was equal to? Slope. That was rise over run, right? And if you wanted to find that from the graph, one way you could do that is you could pick any two convenient points on your graph. And so I'm going to pick -1, 0, and 2, 2, because those look like convenient points to me. And you calculate the rise, which goes up 2. For my run, which is 1, 2, 3. So my rise over my run in this example is a rise of 2 for a run of 3. So my slope is 2/3. All right, let's look at the next example. Is this a linear function? Yes, it is. It is a linear function because it is a nice straight line and it's a function. All right, but what is my slope on this one? Slope. Well, can we compute this the same way we did before? It looks a little different, but let's give it a try. Let's pick two convenient points. How about negative 2, 2, and 2, 2? All right, so my rise from this point to this point is 0. And my run is 1, 2, 3, 4. 0 over 4 is 0. Remember, you can divide 0 by something and still get 0. I can give nothing to 4 people easily. All right, just for fun, let's do the next one. Just for fun. Of course, we're going to do the next one. Let's look at graph number 3 down here, the red graph. Is this a linear function? Nope, not linear. Non-linear. And we know that because the graph is not a straight line. That's all you need to say. Graph, not a straight line. Or even just not a line, but I want to be careful. Graph, not a line. All right, number 4. Take a look at this one. Pause the video and really think about this one for a second. See if you decide if this is a linear function. All right, what did you come up with? It's tempting to say yes, because the graph is definitely a line. And so I kind of led you astray there just a teeny bit. This is the only time the graph can be a line and it's not a linear function. This isn't a linear function because it's not a function, right? It's not the linear part we have trouble with on this one. This one's not a function, right? This really does not pass the vertical line test because it is a vertical line. So this does not pass the vertical line test. Does not pass the vertical line test. So this is not a function. It is a line. It's just not a function. In fact, it's a vertical line. And what is the slope for vertical lines? Do you remember? Well, if we look at this and we try to compute it the way we used to, we have a rise. So if we try to compute the slope, remember it's rise over run. So we pick 2 points. Well, this is a rise of 2 for a run of 0. And remember, whenever you get that 0 in the denominator, that's bad news, right? And so we do something like does not exist or undefined, either one. Does not exist, undefined. That's one way, undefined is another way we write that. And just a quick little mnemonic device. If you take 0 and you divide it by a number k, that's, oh, I'm sorry. Yeah, k, that's okay. Oh, maybe it's right on. Yeah. If you take 0 and divide it by a number n, you're right on, and that's okay to do. Right on, keep going. If you take a number and you divide it by 0, no. Okay? So you can't divide by 0. I forgot exactly how that worked out, but hopefully that makes sense to you. Oops, I'm zooming out. Zoom back in. Okay. Now I'm all blurry. What's going on? Okay, here we go. So let's talk about representing linear functions using function notation. Now that we can identify them from a table, if they're linear or not, we can identify them from a graph. Let's work on their equations. I want you to look at the top one first here. Let's look at the top one first. Let's highlight this guy. This is slope-intercept form, and this is the, whoa, how did I do that? Maybe type Control-Z and do that. I don't know how I did that. Let's not highlight, I guess. I don't know how to do highlighting. All right, that was exciting. All right, the top one, I'll just draw a star by it. How about that? The top one is slope-intercept form, and this is the number one way people usually work with linear functions and linear equations. And hopefully, at some point in your previous math history, you have worked with y equals mx plus b. You should have seen this for finding the equation of a line. Now, when we switch to using function notation, just like we've done with all the functions, instead of writing y, we write f of x. So instead, we write f of x equals mx plus b instead of y. That's really about the only change between those. Now, another one you may have seen is standard form. And this is used when we're solving, there's a whole mathematical theory of linear processes, and standard notation is used a lot in there, but maybe you've used that. We don't use it as much sometimes. And in fact, we use this standard form for a linear equation sometimes. I honestly have never seen this, but maybe it's there. I think I got this out of your book. And then point slope. Some people have learned point slope in the past. If the point slope equation works for you, great, use it. Point slope is a lot for me to remember. I don't know, it just seems like there's a lot of x1s and y1s, and I prefer to just use slope-intercept form. So I won't be using point slope, but if you've seen it in your past and it works for you, that's totally fine with me. You go ahead and use it. All right, So there's a couple important things. Number one thing, we talked about slope already. Remember the formula for slope. It's still the rise over run, y2 minus y1 being your rise, and x2 minus x1 being your run. Okay, so that's really the important thing about slope. And when we're looking at these up here, all these letters that are M, B, A, those are all just representing numbers. All right, so let's go ahead and let's practice using this, get a little bit of a review. So let's recall equations of lines and practice using function notation. So what we want to do is we want to find the equation of the line that passes through the point 5, 6 and has a slope of -3. And then we're going to write it as a linear function. So it passes through the point 5, 6 and it has a slope of -3. So when I do equations of the line, the number one thing I always try to figure out is the slope. And the number two thing I always try to figure out is the y-intercept. And if you follow those two steps, you will always be able to find the equation of your line given whatever bits of information. If you have enough information, first you find your slope and then you find your y-intercept. Well, this one's pretty straightforward because the slope has already been given to us, right? It tells us right here, a slope of -3. So I can just write m equals -3 and that part's done. So now if I'm using my slope-intercept form of the equation, I can fill in what I know. Y equals -3x plus b. That's what I know so far after filling in the slope. All right, step one is done. Slope is filled in. Now I need to find the y-intercept part, the b, right? What does b equal? Well, almost always the way you find the b is you plug in a point you know. Plug in a point on the line. Well, we do know a point on the line. We know the point 5, 6. So I'm going to plug 5 in for x and 6 in for y and solve for b. So I'm going to write 6 equals -3 times 5 plus b. Now I solve for b. So 6 equals -15 plus b. Add 15 to each side. 21 equals b. And now I know b, so I can fill in the b value in my slope-intercept form. Y equals -3x plus 21. And there's my equation, the equation of the line. So find the equation of the line, check. And now we just need to write it in as a linear function. So instead of writing y, I write f of x equals -3x plus 21. All right, so let's just recap. It might have been a little while since you did this, but we found the slope. We plugged it into the slope-intercept form. We wanted to find the intercept, so we plugged in a point and solved for the intercept, put it all together, and got our equation. What if I had asked, find the equation of the linear function that has the point f of 5 equals 6 and a slope of -3? Would anything be different? Well, the answer is no, because we know, since we're good at functions, we know that f of 5 equal to 6 is equivalent to saying the point 5, 6 is on the graph of the function. Those are equivalent statements. So if we know f of 5 is 6, we know it has the point 5, 6. All right, so let's practice this with one more problem. And I would like you guys to pause the video right now and try this one on your own. All right, did you try it? Hopefully you did. Hopefully you remembered how to find slope. If not, we're going to go over it right now. Well, we are given two bits of information about our linear function. We know that f of -4 is -4, and we know that f of 4 is equal to 0. So I'm going to translate these to knowing that since f of -4 is -4, that means the point -4 is on my graph. And since f of 4 is 0, that means 4, 0 is also on my graph. So this is equivalent to finding the equation of find the linear equation that passes through these 2 points, right? So the first thing we need to do, like I said before, is find the slope. Always the first thing to do. Well, we weren't given the slope this time, right? We have to remember the formulas for slope. Remember, y2 minus y1 over x2 minus x1. So this time we actually have to compute the slope. And then the second thing we're going to do is exactly the same. We're going to find the y-intercept. All right, so let's try to find the slope. I'm going to call this one x1 and this one y1, this x2, this y2. And if you labeled it the other way, it'll turn out the same. The slope will turn out the same. y2 is 0, minus y1, which is negative 4. x2 is 4 minus x1, which is negative 4. 0 minus negative 4 is 4. 4 minus negative 4 is 8. So my slope is 4/8 or 1/2. You can write it as 0.5 if you want to. It's fine. All right, so I found my slope. So I know my equation is y equals 1/2 x plus some number b. Great. Now, how are we going to find the y-intercept? Well, we have 2 points this time. You can plug in either one you want. I'm going to plug in the second one because I like working with 0. It makes things easy. So I'm going to plug in the second point. So that tells me that 0. So I'm plugging in 4, 0. So that tells me that 0 equals 1/2 of 4 plus b. So 0 equals 2 plus b. Subtract 2 from each side. B equals negative 2. So my equation is y equals 1/2 x minus 2. And I want to write it as a function because it said to find this linear function. So I'm going to write f of x equals 1/2 x minus 2. All right, awesome. I have another example here that you can do if you want to. I'm going to skip it for now. You can give it a try and see how you do. Oh, wait, that's the end of this video. Well, I'll still skip it. I don't think we need it.